let's have a look at how we can use the quadratic formula when we're graphing our quadratic functions. Now, we've already got quite a few skills that we can throw at these things. We learnt those 5 steps in our first lesson on this. We can look at A and see whether it's positive or negative. That tells us if our parabola is upright or upside down. Then we can sub in x equals 0 to find the y-intercept. We can sub in y equals 0 to find the x-intercept. And we saw that when we go to do that, we're effectively turning our quadratic function into a quadratic equation, which will have some solutions for x, possibly. Maybe 0 solutions, maybe 1, and maybe 2. Now, when we go to solve that, we may be able to factorise, we might be able to complete the square, or we might choose to throw the formula at it. After that, if we've got intercepts, then we know that we can average them to find the axis of symmetry and sub in that x value to find the vertex. Or we've now got another choice, which is that we can rearrange our quadratic function into vertex form, complete the square if we need to do that, and then we can actually just read the vertex straight off. So we've got lots of ways of doing the same thing. So we've kind of touched on the fact that we can use this quadratic formula to solve a quadratic equation, and that's going to be handy to help us find x-intercepts if we can't factorise, or we just would rather do this than complete the square. But we have to remember that there may not be intercepts. So 2 other things that are most important in this lesson, because we've sort of already seen this a little bit already, even though we haven't really practiced it much, is we've got a new piece of maths here, which is a little formula for getting the axis of symmetry. Now, we've found that we can get the axis of symmetry by putting our quadratic function into vertex form. Then we can just read off what that h value is. But this is now another method, and I think you'll agree with me that it's actually probably quicker and easier to do. So why is it minus b over 2a? Well, you'll notice that it's actually just this part here of the quadratic formula. And this makes a little bit of sense, because if you know that the axis of symmetry is pretty much equidistant between the intercepts, and this thing can help us find intercepts, then it makes sense that if we're adding or subtracting something, then what we're adding or subtracting from is that axis of symmetry. So this minus b over 2a, rather than filing this in your head in a new place, file it in the same place where you know this formula, because that way, if you've already memorized this, you basically know that, and you need to just remember that it's just this part of the formula. Now, you don't strictly need to memorize this entire formula, because you'll always have it on a formula sheet in an exam. But if you do memorize it, it can just make it quicker and easier without having to look it up every time. So now to the discriminant, which is the other part of the formula that's left behind there. And the discriminant is not everything there, it's just the part that sits underneath that square root bracket. It's the b squared minus 4ac part, and we often give it this symbol of a triangle. Now, a discriminant is named that literally because it discriminates. In other words, it decides what's going to happen. Now, if the discriminant is positive, then that's all well and good, because we can take the square root of a positive number and we'll get some answer. It may or may not be a whole number. We might have to leave it in surd form, or we might round it off, depending on what we want to do with it. It is just a number though. But the fact that in this formula we are actually adding and subtracting that number means that we'll get 2 different answers to this formula. One when we've added and one when we've subtracted. And by the way, when you're putting something like this into your calculator, just put it in once with the plus sign and then go back and change your plus to a minus so that you can get your other answer. A lot of the time though, you'll want to actually use your knowledge of surds to simplify surds if you need to keep things in exact form. Always check the question, because it will tell you whether or not you need to keep your answer in exact form, which means as a surd, or whether it's okay to round it off. Now, if what we have under the square root bracket is 0, what's the square root of 0? It's just 0, isn't it? So if you're adding 0, will that be exactly the same as subtracting 0? Yes. So that explains why when the discriminant is 0, there's actually only one answer that's going to come out from your use of this formula. So that means there's only one x-intercept. Now, we call these intercepts roots sometimes. So we've already touched on the fact that that will be a special type of intercept called a double root. And that means that the parabola is just going to come down and touch that x-axis in one place. Or if it's an upside down one, it will still just touch it in one place, rather than going through and having 2 intercepts like in this case. Now, what would happen if b squared minus 4ac was less than 0? Well, can you take the square root of a negative number? Well, you can't get a real number as an answer, not in this course. So in that case, we say that there's no solutions. And in other words, if we're looking for x-intercepts, then there's no x-intercepts. And that happens, of course, when you've got a parabola that is upside down and is down below the x-axis, or the right way up and it's sitting up above. So let's put those skills into practice now by graphing this quadratic function. Now, if I was to start by just factorising this, I'd be looking for factors of negative 12 that add to negative 2, and I can't think of any, so I don't think this is factorisable. I could complete the square here, but it's a non-monic one, so I'm thinking I'll just use some different skills here and I'll throw the formula at it. I can see it's an upright parabola, and when I sub in x equals 0, I can see that y equals negative 4. So I've got some information straight up that I can put on my graph. Next step is to let y equal 0 and try and solve for x to see if we can find some x-intercepts. Now, before you leap into using the whole quadratic formula, why not start by working out the discriminant first? So the discriminant is b squared minus 4ac. We're going to need that anyway in the formula, but if we see if this is positive or 0 or negative, that'll tell us whether or not we need to bother throwing that into the whole quadratic formula. There's no point looking for intercepts if it doesn't have any. So start with this, and then you can use your answer to make your quadratic formula a little bit quicker and easier. So b squared, remember b here is negative 2, not just 2. So we've got negative 2 squared, which is 4, minus 4 times 3 times negative 4. I often just put my numbers straight in like that so that I don't make a sign error. I can then clearly see what I've got. So here we've got positive 16 times 3, that's 48. You can use your calculator for this. Obviously, we'll get 52. Now, 52 is a positive number, so I know we've got some intercepts here. So now I can throw it into the entire formula. Negative b, well, if b is minus 2, then negative b is just 2, plus or minus the square root of 52. Now, can that be simplified at all? 52 is 4 13s, so this really is the square root of 4 times the square root of 13, and the square root of 4 is just 2. So I can actually change that in there to 2 root 13 to save myself a bit of time later, over 2a, where a is 3. So 2 3s are 6. Now, is that as simple as it can get? And does it matter? Well, I could throw this into the calculator to see roughly where this sits. But if I'm going to label my axes with an exact number here, I think it'd be nice to get it as good as I can. Now, all three terms here are even. That means I can halve them all. Don't forget that when you halve them, halving this is 1. Don't just cross it out and leave it as a 0 and then put this bit. Lots of you have made that mistake before. Instead, we halve 2, we get 1. We halve 2, we get 1. This is 1 lot of root 13. We halve 6 and we get 3. So now we can say x is equal to 1 plus or minus root 13 over 3. Now, putting that in my calculator is a good idea just so that I know roughly where this is going to sit so that my graph looks sort of roughly right. So the bigger one is round about 1.5, but it's not exact. So let's label that as 1 plus root 13 over 3. And going up there and actually just changing the plus sign to a minus gives me negative 0.86 blah blah blah, keeps going, so that tells me it's a little less than minus 1, so it's, sorry, a bit more than minus 1, so we can put it sort of here, and we'll label that as 1 minus root 13 over 3. That's all I really need at this point to go ahead and rough in my parabola. I can see that if the intercepts are here and here, then the axis of symmetry is sort of off to the side, isn't it? So it's going to come down a bit before it goes back up. Okay, now we've learnt that we could add these together and divide by 2 to get the axis of symmetry, but we've got a great shortcut. We can also just say it's minus b over 2a, which in this case is going to give us nice whole numbers. Minus b is just 2, and 2a is 6. So that tells me that my axis of symmetry is here, and I can label that as 1/3. Now that's going to make my life a little bit easier when I go to find the vertex, because I know that this point here now, find out what you have, is 1/3 comma something, and that reminds me that I need to sub 1/3 all the way back in, remembering this is a y. So I need, let me make some space here, I need to do 3 lots of 1/3 squared minus 2/3 minus 4. Now you can put that whole thing into your calculator and you should have got -13/3. So that will be the y value of the vertex and your graph is complete. Now, would you go through that whole process as opposed to using vertex form? Well, it's up to you. Some people will just find that they're a lot better with one method than another. Use a method that is fast and creates the fewest errors for you. But of course, you kind of need to know all of these methods in case you're asked to do something a particular way and they want to see you work it out that way. So just to compare what the working would have looked like if we'd gone after this vertex by finding, say, vertex form first, we would have started by getting rid of that 3, divide everything by 3, and that would give us this. Then we would leave a line, look at what we're getting to here, halving 2/3, we get 1/3. Multiplying this out again, we get our x, oops, that needs to be an x, we get our 2/3 x, but we also, kind of unwanted, get this 1/9. So we have to take a 1/9 off again, and then we have to subtract our 4/3. Now, since I'm dealing here with 1/9, to make them talk to each other a little better, I could make 1/9 here, multiply by 3, multiply by 3. I've still got my y over 3 on this side. And now these 3 terms are taken care of here, and I've got -1/9 minus 12/9 makes -13/9. Now I've got to get y equals, so I multiply everything by 3, so I need 3 of these, but I also need 3 of these, and multiplying by 3, of course, gives me the 13/3. Now I've got it in vertex form. I can double check. I've got a vertex of 1/3, -13/3, which is exactly what I got with the other method.